So this little short talk is because most of you have heard about what we call the data phenomenon. You can call it smart data, open data, big data. The thing is now what I call the fuel of economy, okay, is data. I don't know if you heard Wozniak today. Wozniak was at a time where hardware was the most important part. Like we needed to bring the device into people's house. Today the devices and connections and people, the only thing they produce actually is mostly data. Data can be content, it could be interactions, we'll see that after. But the thing is, data is today the fuel of economy. Okay, it's the currency. That's how you measure the value of a company today. It's mostly about how much data they get, how much data they produce, and how much data they process. So if you look at this, data is like the matière première, the thing that is produced by the system. From data you get information, you get insights and everything. From these insights you get knowledge, and from the knowledge you get the wisdom. Okay, I like to show this way. Knowledge is everywhere. It's produced by people, it's produced by systems, it's produced by interactions and these kind of things. And the experience you get as a business from this knowledge is just by connecting the dots. The more knowledge you get, the more connections you can get. And the more connections, the better understanding of what you're doing and your customers, for instance, of what people need or what people want, or the emerging markets or these kind of things, always come from this kind of experience. So let's take a look at how the interaction works and where the data is. Because most of the questions come from people is like, where is the data and how do I collect it? Okay, so you have users, they interact with content, they produce content most of the time. The content goes to the device. Let's say I take a picture or I upload the music or I say that I like this kind of information on Facebook. Then it goes to the system, to the application of the system. The system goes to, can add actually data like geolocation, for instance. So it's like metadata if you want. Or time or other things, and this goes to the cloud. Most of the information now goes to big servers everywhere in the world. They call the cloud. We call it the cloud. We don't know exactly what the cloud is, but it's a lot of machines that's everywhere. So you can connect people, but you can also connect machines. Okay, that's the Internet of Things, and the Internet of Things is the next generation of data producer. It's still already producing data, but I would say it's the next generation. Because if you think about it, we moved from a network of computers, the internet, to a network of information, the web, to a network of people, the social media, and now to a network of things. We could connect cars, wash machines, a fridge, telephones, and everything is connected to the network. So data was produced at every stage. The first data was just interaction. The second data was information. The second data, the third data that was produced was the connections between the people and the content. And now we have information produced by machines on us. Like, I was in this mall at this time, at this place. I went online and checked this product, and then I went to this shop and I bought the product. Okay, everything is connected through data and through objects. Your credit card, the payment gateway, the Wi-Fi, everything connects everything. So data comes from this interaction. So you have data on content, you have data on the interactions between the device and the application. You have data between the application, the added data that can be produced by other services, and then the data goes to the cloud. Okay, so this is where you get the money from data. You get the money from data by understanding these different ways of getting. And you asked the question about analytics. This is where it goes. Analytics goes when you get the data, you understand the interactions that's producing the data, and from these interactions, then you get the knowledge and you get the insights and you get the information. Okay? So, of course, every data can go into the analytics, and you can add different layers of data. So let's say, let me give you an example. You're an insurance company, and you have a company that has airports in the US. You want to see on a map the biggest airports in the US with the biggest traffic, so you get the data from airline companies or from the Ministry of Transportation in the US, and then you put on top the number of thunder strikes in the US during a certain period of time. And as an insurance company, you can decide which airport is the most dangerous in terms of lightning strikes and everything like this. And with this data, you can decide on the policy that you will create, on the money that you will get from airports, and this kind of things. Which are the airports that needs more insurance than others, and this is everything about it. Okay, so other type of data is produced by the system itself. Okay, the cloud produce data all the time. So you're getting data from the interactions, and the data goes to the analytics, because everything is connected. And this is a new field called linked data, where all the big data is connected by knowledge. So everything produced by the device can be connected to the people. Okay, when you log into a system, it's not just a phone, it's a person behind the phone. But if you don't log in, nobody can tell who's behind the phone, except if somebody texts your password or something like that. Same with the application, same with the geolocation. Like Google Maps is playing like a very important role in building the linked data. You can link data with the exact GPS position of a person, whatever the application is. You're always using the same reference. And those references are called ontologies. Okay, so you create ontologies of places, of people, ontologies of topics, ontologies of any kind of thing. So this is what we call linked data. And also data is produced at every level of interaction. So for now we call this big data. Why do we call it big data? Because it's big. But I will go back to that after. So data is everywhere. So it is mostly in relationships. So if you want to build an application, and if you want to know what people are doing with the application, you will try to record the interactions. So every piece of interaction should be stored, analyzed. You can do it with Facebook, for instance, Analytics, or Google Analytics, and you can measure the level of interaction. You can actually get the data from these applications. And you have business intelligence, which is the science of understanding the data. But then we will come back after that. So the links between the inferences, the links between humans and objects, and between content and meaning. This is where the ontologies play a very important role. Why? Because when data is big, you see new phenomenon appearing. First of all, you see patterns. You know, Amazon, when they sell you a book, they tell you this number of people actually bought this book, also bought this book. Okay? If you do it with 10 people, it doesn't make any sense. But if you do it with 10 million people, then you will see some patterns emerging, like properties emerge on the large scale. This is why it's interesting to have big data, not just data, but big data. Big volumes of data make sense on a large scale models. That's very interesting. And of course, because you go into qualitative analysis, so you do business intelligence, and you see the patterns. You see, like, for Christmas, a lot of people on Amazon buy presents for their kids. Okay. Big data can tell you that, but I will tell you that this is not enough. And this is why my presentation is called smart usage of data. Because if you get this information from the system, that's what the system will tell you. It sounds like pretty obvious. And you will say, I'm going to pay like $10 million of computer infrastructure to actually have a system that tells me that people buy presents for their kids for Christmas. It's pointless. Okay, so you want to know the why behind the what. And this is why smart is interesting. Look at where the data comes from. So transactions, logs, emails, but also social media, audio, photo, and video. So content, interactions, and system interaction. Take a picture. Okay. So why do we call that big data? If you read the definition, big data is just data that exceeds the boundaries or the limits of the amount of data you can process. For instance, you're an employee of the Roman Empire, and you go to a city and you have to count the people and put their names on stone. 10 names is going to be very long to process. So this would have been big data for Romans. But today, if you're a small company and you have like a limited power to manage data, as soon as the data gets over this limit of what you can manage, you can call it big data. Big data is is according to the size of your computational power that you have in the company. So it's forcing you to take a non-traditional approach. So the challenges for a company would be, how can we analyze all the data that we get? Okay, have you heard about Hadoop? Yes, Hadoop is one of the solutions provided by Google to actually help you analyzing the data and storing the data and capturing the data. But more interesting for a company would be the attributes and the variables that are relevant to your business, called that KPIs. Okay, what's the point of collecting data if you don't know what you're looking for? Okay, you want to know for Christmas what kind of presents people buy for their kids. Okay, so this is one KPI. I want my system to tell me what are the favorite products for Christmas, or where are the people buying my flowers from, or why do people buy this and that. You see, so the KPIs are very interesting. Another challenge is when and why and how can I start to collect the data, okay, and where do I store the data? And of course, if you want to get smart, if you want to go into the extra mile into understanding the why behind the what, then you have to avoid a lot of bias. Like, let's say, I had this guy the other day came and say, we have those devices for hearts, you know, they put like a device that records the heartbeat. And they found out that when people eat too much, like for Christmas or for Thanksgiving in the US, people have more like problems with their hearts. This sounds obvious, and this is what has been recorded. And they thought that, wow, we are very smart, we found out the reason why behind the why behind the what. But is it really the truth? Is it really because maybe in November or December people are tired and then their heartbeat gets slower? Is it really because they eat too much? Or, you know, it would take much more than just having the obvious. I'll give you an example at the end that shows you that. I will skip this, it's a bit technical. So what can we do with big data and data? First of all, we can do a lot of algorithm analysis that will get you to, for instance, analyze the links between objects and information. Or PageRank. You heard about Google's PageRank, like how you rank pages in a research search engine. You can find similarity in data sets. So you have two data sets, as I was discussing the airport and lightning strikes. You have two data sets, you can find similarities. You can find similarity in item sets. Everyone who bought this book also bought this book. Okay, this is kind of things you get from big data. You can also detect community and homophily, like the people who like Star Wars also like this kind of movies. Okay, people who like this kind of music also like Star Wars. You see, this kind of things. You can also do the data streaming live with the big data, which is very interesting because you can adjust, for instance, the price according to the demand on real time. So let's say you see that you have a product that that becomes a big seller for a reason. Let's say some people are talking about a movie on television, and then suddenly people want to buy the DVD of this movie. So the price of the DVD, the demand will increase. So what you're going to do as a system, you're going to increase the price if the demands increase. Okay. But when you get this information in real time, you can get an algorithm that will calculate, according to the demand, the increase of price, which is very interesting if you're running like a live business of like say e-commerce or this kind of things. And you can also recommend the systems, like what we discussed about the similarity in community. We can match these three to get the recommender system. The recommender would be, what is the best book for you for Christmas, according to what you like on Facebook, where you live, what did you buy previously, and this kind of information. Okay, you can also categorize information, which is more like into the data and metadata approach. So and so on. But this is the math, I would say, of big data. And there's a job behind this. It's called data science. The job behind this thing is called data science. And today, if you want to study something, I suggest you all study data science. This is the job of the future. I mean, of the present. Okay, so of course you can find every methods of tracking your data that you're producing by devices, cookies, cookies, profiling, search queries. You can analyze the query. You can do content analysis. You can analyze the language that is used. So it takes a lot of technologies to do that. This facial recognition software that can let you scan people from their face or else. The data that you get can be stored in classical way, structured. But when you get to big data, you have to think about non-structured or hybrid. And I don't know if you heard about non-SQL databases. This is how it works. Because when you store opinions, language, comments, videos, you can't use databases like before. So you have to invent this kind of things for like the I was looking for it, right? Like every kind of weird content that you get from social media, you have to store it in a non-SQL database. The way you store data before was like is finished now. Okay, these are like examples of the tools you can find to manage the big data. So this is to collect the data, this is to treat the data, and this is to visualize the data. It's just a very important part of it. And this is according to their complexity. So the simple ones, of course, Excel, these kind of things. But I would suggest you get interested in this Tableau. It's very interesting software for data analytics. And of course, you have Hadoop on top, Amazon Web Services, Django, which is like the ultimate new languages that you need to learn to do that. Okay, so just a point on how do you get from this massive information that you can collect in pretty easy way actually to the smart, so the why behind the what. There's this guy I like who said the trick of getting value out of data is not how you collect or store it, but how you slice it and dice it. So it's interesting to know that the why behind the what comes from the value of making sense of data. Because data can be either help you to decide or help you to have informed decisions. Because it could be very difficult for a company if you take decisions on just data. Data can give you the big picture, but you need the why behind the what. And to do that, you need to bring in social science, you need to bring in linguists, you need to bring in data scientists that have like some experience on the context and everything. Let me give you an example. I was at a conference last year, and there was this guy presenting a big data research on food in Germany. They gave like amazing information on how people behave on websites talking about food in Germany. And they say, on the weekend, people eat less meat than during the week. Okay, and they said they eat asparagus in January in Germany, like a lot of asparagus. Very interesting information if you run a business. But the smart way would be, okay, it's interesting, in asparagus, everybody will buy them in January. But if you understand why people eat asparagus in January, there's a reason behind that. Okay, it might be because asparagus is cheaper in January. It could be because there's a special dish that is in a special part of Germany where people need a special type of asparagus and they need it in January because that's the time where they eat. You know, you need historians, you need people from social science, you need people from even, I'm trying to find out like people like understanding the psychology of people and everything to make it smart. So, data is nothing more than many sets of little stories put together. And the other day I was at a lecture, and the guy was from a big company. I don't want to name the company, but it's Microsoft. And the guy was explaining how Microsoft has this huge new called Azure. It's a new structure in a platform for big data. It's called Azure. It's very good. They have a lot of tools actually together. But the guy gave an example during the presentation, and he said, yes, but if I show you my data, there's a lot of variations in the way I use Facebook, for instance, because it's based on, I was in the US, so I used it a lot. I didn't have internet when I was in Africa, so I didn't use it a lot. I was on vacation, so I did use it a lot. So if you look at the data from this guy and you put another 10 million people on top of it, the real reason why these inflections happen will be lost in the number of people. But if you really want to serve this guy, there's no way you can get information from data on a large scale. You need to go into the little stories. So you need to interview people, you need to talk to them, you need to go on their Facebook profile, see what they talk about, and do these kind of things, because big data is not enough to give you sense. So data-informed team blend qualitative insights, so social science, history, psychology, with the large amounts of value of data before they make the decisions. Okay, let me give you to close this a little example about Kellogg's. Okay, in 2008 or 9, I think there was a big economic crisis in the US, and Kellogg's was pretty much into trying to understand how would people behave when buying cereals. When there's an economic crisis, what do you think people would do? cheap stuff, small boxes. They went into the data and they found out that people were actually buying expensive quality on big boxes, which is completely not what you think should be the situation. So they decided, like, okay, let's big boxes and make like those very expensive cereals because that's what people want. But then some guy looked into the data, piece by piece. He went to social media platforms, he went to Quora, he went to these kind of things, and he did some big data analytics, and he found out that everything that people were talking about cereals, you could easily find the word garage with it. You know, a garage for cars. What's the connection between cereals and garage for cars? Okay. And they looked into the discussions, into the Twitter, into the Facebook profiles and everything, and they found out that actually people were buying those big boxes of big quality because they would store them in the garage, and big boxes means like better storage in case of economic crisis. Maybe you can't buy them tomorrow, so you buy big ones, but the problem was to store them in a safe place, far from insects and from humidity. So people were discussing how to equip the garage with boxes, plastic boxes, to put the cereal safe for a long time, for the time of the economic crisis. So what the guy said, he said, don't sell them big boxes and big quality. That's what people want, but also sell it in plastic boxes so they can store it safe from humidity and from pests. And this kind of information could only come from a smart understanding of data, and definitely not from a computer algorithm that would just give you like, okay, let's do that. Okay, so never forget that. Yeah, you analyze the data, but that's in the second stage, and this is why I'm talking about data-driven and data-informed. The data-driven team would look at the data and decide what the data says, but the data-informed will look at what the data decides and then discuss it on a different level, qualitative level, understanding the people, understanding the customer, and then go into a different decision. Never forget that the people who when they build a software, when they build an application, when they build something that you use, this device, you see the world through it. You don't see the real world. When you take a picture, you only see what's in the picture. You don't see the outside of the picture. Okay? And this is the same for data. If you look at your data through the tools like Microsoft BI or these kind of things, or Hadoop, you might miss the reality that's behind it. You might miss what's under it or next to it. So never forget about that. And I think I took 15 minutes and 20 minutes instead of 15 minutes. Okay. Thank you. Any questions? Yes?
What are the analytics of the data?
Sorry?
The analytics of the data.
Yeah. I talked about it when I approached the different this different software that you find. Okay. Analytics is one step. You can use any kind of tool if you want to do that, but you need somebody to read it. You need some. It could be a software that reads the data. If you have Google Analytics, for instance, you can take data from different channels. You know that in Google Analytics. Yes, and you can also. It would be very interesting to have, like, let's say, if you have a point of sale in a shop, to import the data from the point of sale and add it to the analytics. Or if you have geolocation data, also add it to the analytics and this kind of thing. So analytics is just a way of processing the data. And as I said, you can't stop here. Once you get the results, you just don't do the visualization and then put it into your report. You have to look at and try to understand what's going on. Because the truth is never, this is the point of my final slide, what you see is only what you see through the tool that you're using for analytics. I don't know if you use Facebook Analytics or Google Analytics, sometimes you don't get the same numbers because they don't calculate the same way. Sometimes the algorithm between the way they calculate is different. So you go to your clients and you say, look at your data in Facebook, and then they say, oh, but we did it in Google Analytics and we had different results. So there's always like a way to actually get to the truth, because there's nothing worse than a decision that might be driven based on fake data or biased data. And this is what I said, like one of the challenges, be careful of the bias. It's very important. No. No, I'm stuck with Hadoop and Tableau, and that's not what I do in the company. If I ask the guy doing the data mining and the data process in the company, they might know this kind of tool. Sorry.
Are you in the data field?
I'm in the science and research field.
Oh, you're a data scientist?
Not data scientist. I'm a social scientist that is interested in a large-scale phenomenon, like big data. But my field is web science. I'm much more into the interactions. So before, I would say you collect the data. But I use big data in my research. When you want to understand a phenomenon today on the web, you have to go through big data. But I have a team for that.
We're gonna enter like in 5 years the bigger data.
Yeah.
I heard lately that the banks are trying to fight against the IoTs. All the IoTs have the key for the bigger data. How are we gonna enter this field with the bank against that?
The problem with data today, and it's not only about IoT or banks, there's no regulations. Personal data is a real problem. You know that we are spied, like the government and everywhere in the world. People are recording data. In France, yesterday there was a problem of 60 million people in the database that is absolutely unprotected and could be stolen or could be altered by people. There's a lots of issue concerning security, storage, but also the way you treat data and when you use data to match things together. You know, an example, I work for the Internet Society on the Open Data Initiative. And one of the problems in England that happened with open data, they produce maps where you can see the people who committed crimes, where they live. And some people from the real estate sector actually took the maps of the apartments for sale and the maps of the criminals where they live, and they matched them. And some sections of London actually lost 50% of the market. They bought the houses and then they altered the data, and then they say we didn't do anything. But you know, that's the problem with the data today. Everybody's afraid of it because it's a real complicated phenomenon, and we produce a lot of data. Like I think just by talking like this, we're producing positioning content. And don't you think that your cell phone is listening to you? You never had this impression that you've been discussing something with a friend, and then after 10 minutes you get an advertising on what you just discussed? Some of the devices, and especially some applications that you install on your phone, can record what you say and analyze the content, do big data analytics on and match you with a profile and send you some advertising. Always, when you install an app, always read, let's say, I'll give you an example. The other day I was installing an application to calculate the rate between euro and dollar. And while installing, the application asked me to have access to my microphone. It says, why does this application have access to my microphone? There's not even like a way to say something in the application. It's because that's what they do. They sell you a currency exchange application, but actually their business model is to record your voice while you're talking and while the application is on, analyze the content and sell it to Google.
Before they used to track us using the hashtag and keywords. Now even by word they can track us.
Images. Go to Google Images and you'll see that they can identify objects in a picture very easily. And now they can identify people very easily. Facebook can tag people without asking you. If you don't remove that option, people can get tagged in Facebook. So behind the data phenomenon, there's a lot of problem with the legal and also with privacy and all these problems. Hey, John. Yes? Privacy. Okay, good. Other questions? No? Thank you, so.